Hello, good morning, students. See, we are discussing about the problem number 18 from H.C.VARMA. That problem is test if the following equations are dimensionally correct or not. So we have to determine here the given equations, they are dimensionally correct or not. So to determine it is dimensionally correct or not, so we must know how we can prove it. See here, in our previous lectures, we have already solved these problems. First problem, that is height. Height is equal to 2s cos theta upon rho rg. Then second problem also we have solved already. Now today we have to solve third problem, that is the next problem, and the problem is v is equal to pi p r to the power 4 into t upon 8 into eta into L. So to solve these particular problems, we must know the parameters which are present in the equations. Now see which parameters are here. So to solve these third number problems, so we must know the parameters. The parameters are like this. So V stands for, capital V stands for what? Volume. Pi, it is constant. Then P stands for what? Pressure. Then R, that is the radius. T, that is the time. Eta, this eta is called as coefficient of viscosity. Coefficient of viscosity. Then L stands for length. Okay, so these are the parameters of given equations, that is V, volume is equal to pi p r to the power 4 into t upon 8 into eta into L. Now we have to check this equation whether it is correct or not. So first of all, what can we do? So we have to calculate the dimensions of each physical quantity which are given in this equation. Okay, so first of all calculate the dimensions of volume. So volume is equal to, we know, that is volume. What is the dimension of volume? That is L3, that is the volume. Dimension of pressure. So we know the formula for pressure. Pressure is equal to what? Force per unit area. So that is force M1 L1 T minus 2 upon area, that is L2. So it becomes M1, this plus 2 goes minus 2 is plus 2 becomes minus 2, so therefore it is minus 1 T minus 2. So this is for pressure. We already calculate this pressure in our previous lectures. Then radius. So dimension of radius, that is, radius means what? Just it is a length, therefore the dimension of radius is L1. Then after radius, time is there, so the dimension of time, that is obviously T1. Then coefficient of viscosity. Now we must know the coefficient of viscosity, that is eta is equal to. So to calculate the dimensions of coefficient viscosity, we must know the formula. And the formula for coefficient of viscosity is eta is equal to, that is force divided by area multiplied by velocity gradient. So this is the formula, force upon area into velocity gradient. What is velocity gradient? Velocity gradient means what? Velocity gradient. Velocity gradient means velocity divided by distance What is the dimension of velocity? That is L1 t minus 1. So just we have to calculate the dimensions of velocity directly. See here. See here, eta is equal to, that is the dimension of force, m1 L1 t minus 2. Then area, that is L2. Velocity gradient, the formula for velocity gradient is velocity upon distance, that is velocity L1 t minus 1 divided by distance L1. Now which terms are getting cancelled here? So L1 will get cancelled. The remaining terms we can write, remaining terms, eta is equal to m1 as it is, this L2 it becomes minus 2, so plus minus 2 it is minus 1, then t plus 1, t minus 1, so it becomes t plus 1, so minus 2 plus 1 it becomes minus 1. So the dimension the dimension for eta stands for what? Eta means coefficient of viscosity. So see here, eta stands for, that is the coefficient of viscosity, and to calculate the coefficient of viscosity we have this dimension. So this is the dimension for coefficient of viscosity. This is for volume, this is for pressure, then radius, then time, then coefficient of viscosity. One quantity is remaining here, that is length, and we know length, the dimension for length, that is L is equal to L1. So see here, we have already calculated here the number of physical quantities, in dimensions of number of physical quantities. Okay, so concentrate on this equation, that is volume is equal to pi p r to the power 4 into t upon 8 eta into L. So see here, this pi, it is constant because it has value 3.14. This 8 also number, so it is also constant. Okay, so we do not consider these two terms, that is pi and 8. Only remaining terms we have to write. So what is the remaining terms? Remaining terms is here, volume is equal to, this pi and 8 both are constant. Okay, because pi has constant value 3.14 and 8 is the number, so therefore we cannot write these two constant numbers. Just we have to write pressure P, then r to the power 4, then small t divided by eta into L. So just we can write in this way. Okay, so after calculating the dimensions of all physical quantities, we have to put that dimensions in that particular equation. So we have to put the dimensions in this equation. So volume means what? That is L3 is equal to pressure. So dimension of pressure, that is m1 L minus 1 t minus 2, r means radius, so it is L4, and t means time, that is t1 divided by, see here, so see here, pressure, so just put the dimension of pressure here, m1 L minus 1 t minus 2, r to the power, r means what? Radius, that is the length, so that's why we are writing here L4, t, that is t1, and coefficient of viscosity, the dimension of coefficient viscosity is m1 L minus 1 t minus 1 into L. L means what? L1. So now we have to calculate these equations. Now see how we can calculate this given equation. L3 is equal to, see which terms will be cancelled here. M1 get cancelled. Then L minus 1 L minus will get cancelled. Okay. Then remaining terms we can write here. So remaining term will be here t minus 2. Then L4 T1 divided by t minus 1 and L minus 1. Sorry, L1. T minus 1 and L1 remaining terms in denominator. Okay. So we can solve this equation like this. So L cube is equal to, see here, this minus 1 becomes plus 1. So plus 1 becomes plus 2. So t minus 2. Then this L1 becomes minus 1. So 4 minus 1, that is L cube. Then this t minus 1 becomes here plus 1. So here t plus 2 is here. Okay. So therefore L3 is exactly equal to this minus 2 plus 2. It becomes L0, because minus 2 plus 2 0. So T0 is there and L cube is there. So remaining terms is only L cube is exactly equal to L cube. So this is the equation which we have to prove, that is left hand side and right hand side both are equal. So now see here, according to this solving the problems, our conclusion is whatever may be the left hand side, it is exactly equal to right hand side. So our conclusion is LHS is exactly equal to RHS. So both sides are equal here. So therefore this given equation is correct. Given equation is correct. So in this way, if whatever may be the equation which is given to us, so using dimensional analysis we can prove it is correct or not. So this is the third problem which is taken from H.C.VARMA. You have to try to solve this problem for practice. Okay. See here, we already solved here question number 1, 2 and 3. Okay. So next problem we will discuss tomorrow. Okay. Till then, thanks.